Wildfire. What do you think of when wildfire is mentioned? A destructive force of nature, perhaps? Well, when it comes to wildfire, destruction is not the full story. In most places, the historic pattern of wildfire on the landscape has been disrupted. These patterns, that include fire frequency, seasonality, intensity, severity, type, extent, and spatial pattern, are called the fire regime. In order to bring an ecosystem back into a healthy balance with fire, it is critical to understand the characteristics that define its fire regime. This video is part of a series that delves into the intricate world of fire regimes in the southwestern United States. These fire regimes tell the narrative of how landscapes have co-evolved with fire over time, providing insight into the important ecological role that wildfire plays in shaping the diverse ecosystems of the Southwest. Pinyon juniper vegetation, often just called PJ for short, covers some 100 million acres in the western United States. It provides economic products, ecosystem services, biodiversity, and aesthetic beauty to some of the most scenic landscapes in North America. Pinyon and juniper trees dot arid landscapes across the west in the transition zone between semi-arid chaparral and desert shrub or grasslands and large pine forests at elevations between 4,500 and 7,500 feet. Pinyon and juniper are relatively short trees, many not over 10 feet tall. Despite their generally short stature, research shows that many pinyon juniper trees are ancient, having lived undisturbed for hundreds of years. Pinyon juniper communities are one of the most common vegetation across the West. They cover diverse topography, soil types, and climates. Because of this variation, researchers and land managers will say, not all PJ is PJ, which is to say that differentiating them based on similar characteristics can be helpful for research and management. To better communicate these differences as they relate to fire regimes, we have used the definitions provided by Rami et al. 2009, which splits PJ vegetation into three types: the fairly dense persistent pinyon juniper woodlands, pinyon juniper savannas that have a more open pattern with larger spaces between trees and a more diverse understory, and pinyon juniper wooded shrublands, which are a shrub community that sees increases and decreases in tree density depending on moisture level and disturbance frequency. These three types of PJ experience different fire regimes, have been affected differently by the fire exclusion era, climate change, and human use, and are managed in different ways. In this video, we'll focus mostly on the dynamics of fire in the PJ woodlands vegetation type and offer insights into the other types as science currently understands them. The role of fire in persistent pinyon juniper woodlands is better understood than in PJ savannas and shrublands. The higher vegetation density in PJ woodlands provides researchers with clues about what these communities looked like in the past through the study of tree rings, called dendrochronology, and plant succession. Studies involving dendrochronology in more fire-resistant conifer forests use fire scars to identify the exact years of fire events. However, this does not work well in PJ communities. Pinyon, pine, and juniper trees have thin bark and low canopies and are highly flammable. They rarely survive intense fires, so fire scars aren't always available. Additionally, the tree's dense wood and gnarled shape is notoriously difficult to achieve a successful tree core needed for counting tree rings. So how can scientists learn about the historic fire regime in these ecosystems? They have to become detectives to decipher patterns of disturbance by looking at forest characteristics. Plant succession, or the order in which plants regrow, can help researchers understand the time between high-severity fires. Unlike forest types, where the establishment of new seedlings promptly follows fire, pinyon and juniper may require many decades to reestablish. By knowing how quickly certain plants establish and which plants return first, a time-since-fire sequence can be reconstructed. Now, let's discuss what a fire regime is and what the fire regime looked like historically in pinyon juniper persistent woodlands. A fire regime is characterized by temporal attributes including frequency and seasonality, the characteristics of magnitude, which describe the intensity, severity, and fire type, and spatial characteristics, which involve the size and spatial pattern of the fire. These components have a strong influence on vegetation recovery, plant succession, and ecosystem structure. Fire frequency is a measure of how often fire returns on average to an area. Prior to European settlement, fire frequency varied greatly in persistent pinyon juniper woodlands. However, fires in the past were generally very infrequent, on the scale of 200 to 600 years. Some areas have seen fire even less often. Scientists have found pinyon and juniper trees that are close to 1,000 years old and do not show signs of ever having experienced wildfire. Fires in Pinyon-Juniper Woodlands were historically seasonal and occurred during the hot and dry days of early summer and were often ignited by lightning from early monsoonal rainstorms. The summer monsoon in the southwest often starts with dry lightning over these semi-arid landscapes. Because the ground is typically very dry at the beginning of the monsoon, little to no rain reaches the ground, but lightning still does. Dry lightning combined with high summer temperatures and dry or drought conditions can quickly spark a wildfire. Researchers believe that it is likely that fires were ignited outside the normal fire season by indigenous peoples, but little is known about indigenous burning practices in PJ woodlands. Most of the fires in persistent PJ woodlands were of high intensity, meaning that high levels of energy in the form of heat were released, and would produce high severity effects, meaning that the fire greatly impacted the plant and soil communities. In Pinyon-Juniper Woodlands, where surface fuels are scarce, infrequent crown fires occurred during dry, warm periods that coincided with heavy winds. Flames from wind-driven fires would jump from crown to crown and killed most or all the trees in a patch, regardless of the tree's size. Fires would also kill shrubs, though some species of shrubs would only be top-killed and would later resprout from their roots. Low-severity surface fires were likely uncommon in areas with a higher density of PJ, such as in persistent woodlands. Surface fires were more often seen in pinyon-juniper savannas where they killed young trees and prevented PJ from becoming more prevalent. We often attribute spatial patterns of fire to fuel availability, arrangement, and continuity. Fire in PJ woodlands often left a mosaic of burned and unburned patches due to a scarcity of surface fuels, the rocky terrain, and rugged features of upland sites where these woodlands are commonly found. Patchy, high-severity burns would result in landscape-scale heterogeneity with different stand ages. While most fires were small, historically, fires in woodlands on some landscapes could cover hundreds to thousands of hectares. If winds were persistent, fire could burn hundreds of acres within a matter of hours. Persistent pinyon-juniper woodlands have exhibited some major changes over the past century. Heavy livestock grazing, especially in the late 1800s, fire suppression, and a period of higher moisture in the 20th century have allowed an enormous increase in density and crown cover of pinyon juniper. Additionally, in the past 20 years, areas across the West have experienced a substantial decrease in the number of pinyon trees due to a mortality event which has been attributed to climate changes, drought and hotter temperatures, as well as insects, a bark beetle outbreak. Drought has also killed or killed back large swaths of juniper. Today, one of the biggest impacts to pinyon-juniper woodlands in some parts of the West is the cycle of high-severity fire in areas where invasive species are present. One of the species that poses a threat is cheatgrass, an invasive annual that often outcompetes native annuals and is highly flammable. Cheatgrass can completely alter the fire regime and lead to a type conversion in PJ woodlands to a different ecosystem dominated by non-native grasses. Shifts in the wildfire regime toward more frequent and more severe fires have the potential to consume large areas of pinyon-juniper woodlands. Once gone, these woodlands might require centuries to return or could forever be altered into permanent invasive grasslands, which would have deleterious impacts to watersheds and wildlife habitats. In addition to cheatgrass, land managers have been concerned by the increase in the density of PJ woodlands and the infill of PJ into grasslands and savannas across the Southwest. While researchers debate the exact cause of the increase of these trees, there's a general consensus that the degradation of persistent woodlands is not chiefly a result of the fire exclusion era, but is due to a combination of factors including historic heavy grazing that impacted soil and understory plant communities, as well as ongoing and episodic drought. Across much of PJ country, management is focused on thinning trees to increase understory plant communities for wildlife and domestic grazing in areas where trees have encroached on savannas. In other areas, management plans include planting to increase the number of trees or sometimes just the number of pinyon, which is important for indigenous cultures and wildlife. The planting of understory species also occurs to enhance habitat or reduce the risk of invasion by non-native species following disturbance like wildfire. A myriad of other management objectives can include thinning or burning to reduce fire risk around critical habitat, structures, and other assets, to protect cultural resources, and to add resilience to watershed health. The twisted and knotted forms of pinyon and juniper trees are iconic to the Southwest landscape. Despite its widespread distribution throughout the western United States, the ecological resilience of PJ can be undermined in some areas by the expansion of urban development into wildlands, pests and pathogens, grazing, cheatgrass and other invasive species, severe wildfire driven by high winds, and increasing temperatures paired with changes in precipitation. Increasingly, PJ woodlands require active management to maintain important ecosystem function and services like air and water quality, wildlife habitat, carbon and nutrient cycling, and human uses such as harvesting, grazing, recreation, and indigenous cultural uses. By using the best available science and monitoring to inform management, we can work to understand the impacts and develop place-based strategies to maintain and restore functional, resilient pinyon juniper ecosystems.